Good evening, everybody. Welcome, and thanks for joining. This is SVR304, Bots and Serverless. My name is Vishal Singh. I'm a product manager on AWS Lambda. And today, we're going to talk about building bots on serverless. What should you expect out of this session? First, we're going to talk about building basic bots on serverless using AWS Lambda and API Gateway. We're going to talk about some frameworks and resources which developers have been using to build these chatbots. We're going to do a quick shout out to the AWS Slack Hackathon winners and talk about some use cases and the winning bots. And then we'll go into Amazon Lex, which was announced yesterday, to start building conversational interface bots. And then that would follow with a walkthrough of the entire bot building using Amazon Lex and AWS Lambda. And then we are going to go into an advanced topic of how you can integrate these chatbots with mobile applications, as well as how can you get secure enterprise data into your bots. With that, let's get started. So let's talk about how do you build basic bots on serverless. What are chatbots? Chatbots are these new apps. Businesses of all sizes, and individuals too, are building chatbots to interact with each other. Businesses are also using chatbots to extend their platform. There are certain key characteristics of a chatbot. For you to build a good chatbot, it needs to be natural so that it feels human-like when you interact with it. It needs to be available on demand, so there are no installation to do. This chatbot needs to be accessible. What that means is that it is available in your messaging interface. And then the chatbot needs to be efficient, which is it should be lightweight. So that's chatbots. And now let's get into what serverless is, and then we're going to connect back the benefits of serverless to chatbots. We're going to talk about two services, AWS Lambda and API Gateway, as building blocks for a basic chatbot. AWS Lambda. So AWS Lambda is a serverless compute service. It allows you to run your code in response to events. These events could be updates to your DynamoDB database, object puts into S3, or invokes from an API endpoint. Sorry. It has few key benefits. The number one being that code is all you need, which means there is no need to maintain any infrastructure, no need to manage any servers. You package the function code, give it to AWS Lambda, and Lambda is going to run it for you. It also scales dynamically to the rate of events. So as the rate of event increases, AWS Lambda would create instances of your function and scale dynamically. So you don't have to worry about that. The cost benefit. So you never pay for idle. So you only pay for the extent to which your Lambda function is running in increments of 100 milliseconds. If there are no invokes to the function, you'd pay nothing. And AWS Lambda is a high availability and fault-tolerant service. Let's look into API Gateway. So API Gateway, especially in this context, is a companion service to AWS Lambda. API Gateway provides a way for you to create serverless APIs. These APIs are able to withstand hundreds and thousands of incoming requests, and also provide all the all what is needed for it to do traffic monitoring, securing the incoming request, as well as doing versioning. So let's go into the benefits of API Gateway. As we said, it provides a unified API endpoint to your services, to the backend. It provides DDoS protection, as well as throttling, because it needs to match the rate at which your backend can handle. As well as there are mechanisms in place which it uses to authenticate and authorize these incoming requests. Quick recap on serverless apps, and then we'll get into the chatbots architecture immediately. So we talk about there has to be an event source. These event source would send triggers. The Lambda function invokes for these triggers. And then the Lambda function is what holds your business logic. In this particular case, it would be the BART logic. And it would talk to other AWS services. It can talk to any third party or other endpoint. And that constitutes a serverless app. Let's put Lambda and API Gateway together. And when you do that, what you get is a basic webhook built out of API Gateway, which is in front of the Lambda function. The Lambda function can talk to other AWS services, for example, DynamoDB, and to other endpoints. And when the mobile application or a chatbot is going to talk to API Gateway, it's going to send the request to API Gateway. API Gateway would get the incoming request. Excuse me. It would validate that request, make sure everything is good, and pass it along to Lambda function. Lambda function would have, within its execution role, would have access to call other AWS services, and that's when you would have your basic chatbot available purely on serverless. There are a couple things to note here. Number one is intent resolution is something you will have to handle, in this case, in your chatbot. Natural language processing is something it's a heavy lifting, but there are lots of libraries available, or you can build your own. Authentication is another thing where API Gateway provides you a mechanism for you to verify these incoming requests. And then, as a starting point, one thing to note is we have partner integrations. Some blueprints are available, for example, for Slack, for Twilio, for HipChat, and you can get started building a basic chatbot. So the workflow for a basic chatbot is like this. Upload your function code, which has the bot logic, the bot function logic, to Lambda. Set code to trigger on API Gateway. So create an endpoint. It's a one-click automatic endpoint. And then you integrate this webhook to your messaging service of your choice. Test your chatbot, and there you go. You have a chatbot available. Developers have been using lots of frameworks and integration to build these basic chatbots on serverless. Let's go through some of the key ones. AWS SAM. So we recently released AWS Serverless Application Model. It's a generic specification to specify your serverless applications, in this particular case, chatbot. It also helps in quickly deploy these chatbots via CloudFormation. And then there are specific community frameworks, a couple of these as Claudia Bot Builder, serverless.com, these two specifically for Node.js development. We're also seeing that other platforms are now using Lambda to extend their platforms. Today, Motion AI, this is a chatbot platform, announced ability to create custom modules on AWS Lambda. So Motion AI is a chat platform which allows you to create chatbots easily using a visual interface where you would use these pre-built modules, for example, yes and no module, or a module to validate email addresses. With Lambda, now you can create a custom module in your workflow, be it any arbitrary piece of code for your use, and then there you go, you have created an extended chatbot workflow. Now is the time for a quick shout out. So we recently organized, along with Slack, AWS Slack Hackathon. We had participants from over 650 registrations and 70 full submissions, along with GitHub repo of these basic chatbots using the API gateway and Lambda, sort of that basic model, along with the videos and details of their use cases. It was enlightening to see the variety and creativity of these submissions. There were various frameworks used. A lot of people created their own framework. And the use cases varied from a very popular chat apps, because we're talking about AWS and Slack, so that's a very, very popular use case. So there were a lot of submissions around that. But we also saw a very unique and interesting scenarios around virtual assistants, booking your travel. A lot of bots were around social collaboration, education, and the list goes on and on. I'd quickly like to call out the winners, which are, I think, 4 or 5 of these were around the chatbots and chat apps based use case. Clive, for example, to manage your EC2 servers, AWS Network Helper for troubleshooting networking, Marbot to send AWS signals to the DevOps, Service Bot to connect humans to machines to enterprises, Obsidian to collaboratively manage infrastructure. A lot of these used libraries to do the natural language processing, but they were all built using that basic serverless model we spoke about. And these were around the DevOps. But we also saw Eva, that was a virtual assistant managing your travel. We had a little bot to handle classroom interactivity in terms of quizzes and feedback. We had Borges, which would translate from one language to another. And we had the bot, which was how socially colleagues could get together and figure out where to eat. So you see like a sampling of very interesting use cases. When we share these slides, you would see the link to all the 70 submissions. I would highly encourage you to take a look at those. They have the GitHub repos and lots of other interesting information. I think a lot of these winning candidates should be here with us. I would appreciate a quick round of applause for the winners for the AWS Slack Hackathon. So as we've seen, with the basic building blocks, both showcased by the hackathon as well as otherwise, and there are some architectural recommendations I would like to share with you. Number one is around authentication and authorization. API Gateway, as I mentioned, provides mechanisms to validate these incoming requests as it gets into your chatbot. A popular use case is to use custom authorizers. These are Lambda functions, which you would attach to an API gateway seamlessly, and then put in your validation code in there. For example, if a request is coming in from Slack, and you have a signature as part of one of the auth headers, then you could write a Lambda function and ensure that you get the right signature, and then you pass it along to the backend, so that you're protecting your backend and making sure you're doing that due diligence. Environment variables is another one which we recently announced. This is a good practice to separate out your configuration from your code. And so that whenever you are moving from a dev, for example, a dev stage to a prod stage, you don't really have to recompile or redeploy your Lambda functions. You could change the configuration and then move it along in your pipeline. Today morning, we also announced some helper libraries which would help you easily encrypt if you're storing any secret information in the environment variables to do client-side encryption using KMS. Chatbots, a lot of times, have to have some sort of a persistence to add value to the end users. Lambda, as you would know, is a stateless mechanism, so that it doesn't have any state. The next time Lambda wakes up, it starts fresh. So we have seen a lot of folks using DynamoDB for database, S3 for storage, if they want to persist that information. And then one more valuable sort of recommendation would be to think about which platforms you would want to target, because a lot of these messaging platforms have different outputs, experiences. So you would have to create your bot logic so that you can account for more than one messaging channel. So now let's move on to the next stage of, while the API gateway and Lambda, when combined together, provides a serverless webhook, which you can integrate in your various applications. And it takes care of a lot of developer challenges when you're building these chatbots, especially around no need to manage infrastructure, authentication, testing, and a lot of these serverless advantages. But we've been hearing from developers like you guys that speech recognition, language understanding, the areas of adding conversational interfaces to the chatbots is a very important one for the experience of these chatbots. And that has been a pretty big challenge. That yesterday got changed. With Amazon Lex, now all developers have the ability to create these very powerful conversational interfaces on their chatbots. So what I'm going to do is talk about the features, benefits of Amazon Lex, and then how do a complete walkthrough of building a bot using Amazon Lex and AWS Lambda. So there are quite a lot of interesting features in Amazon Lex. It's a complete chat platform. The first and foremost is the big challenge which we were talking about, is now developers have the ability to integrate voice and natural language understanding in your chatbot. It's powered by the same technology as Alexa. And so it's very powerful, and then it would allow you to add those the same functionality in your experiences. And let's talk about how would you add those. Another pain point has been multi-platform. So currently, Amazon Lex is going to easily provide you to publish your chatbots to Facebook, and we'll get into the details of how seamless that interaction is. And the integrations with Slack and Twilio are coming very soon. And this is an interesting one, where the Amazon Lex provides a complete chat platform. So that has lots of tools and helpers which are available to you with a lot of features to do a complete chatbot development through the entire life cycle. It has versioning and alias support, very similar to if you're familiar with Lambda. It has the same model as Lambda. So you can have versions of your intent slots, and we'll get into some of the details on what those are. Helps in multi-developer environments. If you want to roll back quickly, so that is also very helpful there. Chatbots are also developed in a very iterative manner. So I think versioning and aliases are quite powerful constructs to have, because you're going to continuously get feedback and keep improving these experiences for your customers. And aliases are entities which point to various versions, so that you don't have to keep changing the prod and dev version, for example, and they provide easy pointers too. You can have different aliases for different messaging environment platforms, for example, or you can target different groups based on aliases. And then, of course, a very common use case would be the dev, staging, production environments and their configuration using these aliases. Let's take a look at what is a typical Lex Bot structure. One of the bigger, most important one is the intent, which is what is the purpose of the bot. Some of you who are familiar with Alexa, it follows exactly the same model of Alexa in terms of intent, utterances. So an utterance is how you, these are phases which are examples of your intent. For example, if you want to book a hotel, it would say, I would like to book a hotel. I would like to book a room. Can you help me book your hotel? Or I want to book a hotel in New York City. So these are all samples. And you provide these samples, and then Amazon Lex is going to start building your model for you, so that you don't have to specify each and every combination of what is going to be entered for your chatbot. You just have to specify a few, and you would see the model take care of the rest. Another concept is a slot. What these slots are input parameters, so that you provide the context into what is the what are you trying to achieve. For example, in the example of I want to book a hotel for New York. So you know that one of the examples is, okay, location. This is a slot. New York is where I want my hotel room to be. The other important parameters, which are the required parameters, is when do you want to book the room? So what is your check-in time? What is the checkout time? So these three are examples of slots which you have for your chatbot. And then what Amazon Lex also provides is the slot elicitation. What this means is that you have this dialogue conversation going on, where for your required attributes, Amazon Lex is going to ask the users in the language of the prompt which you have specified, so you can customize that, and ask for that, okay, you've provided in this example, the location is New York, but what is the check-in date and what is the checkout date? And it'll continuously ask you for the user to provide that information. And once you have the complete information, is where the fulfillment step happens, which is nothing but AWS Lambda-based function or your business logic. And you provide the input parameters to the Lambda function, and the Lambda function would do the fulfillment. Also to note is there are lots of applications which are existing applications which would want to add the conversational interfaces to improve their experiences, and they already have a backend. In that particular case, you have an option so that you don't have to choose Lambda, but you could say that, okay, return me the intent and the slots which Lex had identified, and you would handle that. Putting this together, I want to book a hotel room in New York City. The Amazon Lex model would automatically figure out that the intent here is hotel booking. One of the slots, New York City, is actually provided by the user. It would do the slots elicitation, and then find out the check-in date, checkout time, ask for a confirmation from the users, send it to Lambda function, and then give out the confirmation to the user. So, that would be the workflow. In addition, as I mentioned, that Amazon Lex is a complete platform for your chatbot. So it would provide, similar to the versioning and aliases, building capabilities, publishing capabilities, trying it out locally so that you know that your the dialogue elicitation is working on well, and so you have all of that built in. And then monitoring is very important. So especially you would want to see, as I mentioned, that chatbot development is a very iterative process. You would want to try out what works and what doesn't work. So you would want to see which utterances were missed. So they were not picked up, they were not fulfilled. So that's another metric which would be available to you to improve your bots. Request latency is also important because as you can imagine, when we are saying that the interaction with the bot needs to be natural, you expect a certain latency for those interactions. So those two metrics and many more would be available as part of the platform for you to improve it further. Let's take a look at what Amazon Lex technology stack looks like. So at its core, as I mentioned, it is built on the same technology as Alexa. So you have the automatic speech recognition and their APIs, the natural language understanding backed by all of the machine learning models and the AI aspects of Alexa is what's available to you. It's also integrated with a variety of AWS services. For fulfillment, of course, AWS Lambda, which opens up the gate to integrate with any services, internal or external. It's also integrated with Amazon Cognito, which is the identity service from AWS, also helpful with syncing of data. Then you have integration with CloudTrail, which would audit all of your utterances and useful for the transparency aspects, which is very important. And then you have, of course, CloudWatch integration, which would do the logging for you. Let's take a look at a complete walkthrough. For the purposes of this talk, I had actually created a bot, recorded it, so that I can showcase the entire development from starting with, think of it as 3 parts. We would use AWS Lambda to create the backend for your bot. Then we will use Amazon Lex to create the intent slot and the entire intent slot model for your bot. And then we'll integrate this bot with Facebook. So it would, I'll do the narrative as we go along building this bot to see how easy and seamless it is to create one of these examples. In this case, this is the Moviepedia bot, and the bot is gonna ask for what's the name of the movie and certain additional details, like you could say actors or year, and it should be able to respond to that. So with that, let's see this. So to begin with, the number 1 step is creating a Lambda function. So you would go into the Lambda console and go and create a Lambda function. Lambda functions could be created in Node.js, Python, Java, and today morning we announced support for C# on .NET. What you see here is a blueprint store. So there are more than 50 blueprints which are available to you for your Lambda function. In this particular case, it's a custom Lambda function. So we chose a blank slate. You describe the information about, OK, what is the name of the function? What does it do? In this case, hey, this is, I want to ask about my movie. My runtime is Node.js, which is one of the popular languages for chatbot development. You have a zip of your code. You upload it. A quick look at, there is a simple code. That is the length of the code here, which can do, something like that. You have a handler. Handler would call a method called dispatch, and that is where it's using one of the open source libraries to gather the information about the movies. You package this library, upload it to Lambda. You can actually upload it right in the console or put your code in S3. So all those mechanisms are available. And then you, in this case, choose a role. So you make sure that, hey, Lambda has access to which other AWS services, provide that integration, keep the defaults, and then click on create a function. And that step creates the backend bot logic for your chatbot in a basic chatbot case. We'll give it a moment. And then, a good practice is to test it out. So you can actually provide the JSON input to your chatbot. In this case, the name of the movie. OK, this is Avatar movie. I want to know, like, one of my favorite movies, who's the director. And you run the code, and you would see the director of Avatar is James Cameron. And you've tested it. You come to Amazon Lex, and you create a bot. And this is where we would create the intent and slots, give it few phrases. You could see that there are some samples you could use. In this case, we just use a custom app and point you to the Lambda function for the fulfillment. Another thing to note is you could do output as voice, or in this case, it would be a text-based application. So that's why I didn't choose the voice. Your chatbot is created. And then the next step would be to create certain slots. We call them slot types. They could be reused across other bots. So they would always be available for you. And so that's why we call the slot type. And whenever you are actually creating a bot, you would create an instance or a type of that. And I'll show you what I mean by that. So in this case, as I mentioned, there are two inputs. One of them is what's the movie name. So I'm creating a slot type of movie name. And the other one would be the movie details. And I'll give you certain values so that the model can understand that I'm talking about, OK, the movies, Titanic, Angry Birds, and so on, so forth. And I'm only going to give them these few values, and the model is going to take care of the rest. So the fourth movie name, it will figure out that that's the name of a movie and match it up. The other slot type is the detail of the movie. And for that, we're going to add the various other attributes of the movie. For example, like who's the director, who's the actor, what year the movie was made, and so on and so forth. And you would see on the left-hand side, your slot types would show up, and you could always reuse them for other purposes. The right-hand side, for some reason, got cut, but that save button, and there is a publish button you don't see. And then you create the intent, and you have pre-built intent. In fact, you have pre-built slot types too, which you can reuse. So a lot of like ask whether and things like that are already inbuilt. So all the entire model for those pre-built intents is available for you. So you don't even have to specify the other details. You pick an inbuilt intent for that purpose. If it's available, you create a Lambda function, and it's the chatbot's done. And then, as we said, that it needs for its model certain utterances. So in this case, hello Moviepedia, which is the name of the bot. I would like to know more details about a certain movie. Tell me about this movie. And you can specify the slot which you had created along with the movie, with the utterance. And so in that case, it is a name type. And we would say, OK, these two slots is what is required for before the fulfillment for this utterance can happen. It's a movie type. I can say which prompt. You can customize the prompt to what you like. The first one was name. We made it a required input. Then the other one is the summary, which is the detail of the movie. And so these are really like, what is the context so that we can provide the input to the chatbot so that it understands which movie I'm talking about and what do I really want to know. As soon as I provide that information, it will be able to act on it. There are options where you can do validation. So you may want to do certain validations about whether this movie is valid or not. That could be a Lambda function. So you can do all kinds of validation on every input which is coming in using a Lambda function. The function would validate, get back those details. You can also have confirmation prompt. And here, this is where the fulfillment association happens. As I had mentioned, that you could choose a Lambda function, or you could just return the parameters if your application already has the logic. And then you build it. So build is a step where it's ready for testing. And you click on build. Save would just save in the database. Build would create you ready for testing. And let's try it out. So we'll say hi. sorry, it got cut a little bit, but welcome to Moviepedia. What movie would you like to want? Avatar, what information? I said I want to know the director. And please note that as this is happening, Lambda is getting called, getting you the result. And that got cut, but trust me, that was James Cameron. And then on the version in aliasing, this is where you specify that for my bot, I have a prod version, and I have a dev version. Dev version always very similar to, as I mentioned, the Lambda model would be $latest. And when you publish it out, you would have new versions. You would have versions at bot level, slot level, intent level, and so multiple teams, multiple people, individuals can work on their models independently, and manage that development. And now the third piece, which is now my bot is ready with all of the conversational interface capabilities, and I want to publish it to Facebook. So this is where it would go, check on the details around, like, Facebook requires, give me these 3 pieces of information. What is my page access token? What is my app secret key? And, what's my verification token? You provide that information. And this is where, like, you have to create a messenger app, and you should subscribe it to a page. And that is where the Facebook is already, for your bot once you've done this integration. So those 3 pieces, we've copied over the access token from Facebook to Amazon Lex from the model, the app secret key, and the verification token, which only you've provided it to Facebook on your app. And we're just copying that over. Click on activate. This is all happening within Lex. And then you get an endpoint, which is the webhook. You copy over the webhook. You put it in the Facebook, and that's your dual handshake, where Facebook provided you the access permission, and like you've put in all of that, and you have a webhook which you have put in into Facebook, and the bot can understand each other and can start taking requests. Yeah, I think I spoke too fast. This is where it shows how you subscribe to the page and do that integration. And once you have the page, you come back, you publish it. This is where you can choose whether this is a dev or prod using that version you have, and it's publishing the movie bot. It says that bot version is 1. So remember, it was $latest. Now it's 1. It also has some more information, like here's what is the connection information for mobile, etc. And let's now try it out. We ask the same questions. Hi. It says, welcome to Moviepedia bot. Which movie do you want to know about? Say Avatar. And what information? I want to know about the director, the same example we've been using, and it comes back with the response. And so I'm with probably a little bit of edits, but this is the end-to-end flow of how I was able to create an entire model in Alexa for the conversational interface, create or reuse my Lambda function, and then connect it together to publish it to Facebook. As I had mentioned, right now we have the integration with Facebook. Slack and Twilio are coming very soon. And so these are some of the typical use cases where Lex could be used for. Informational bots. So these are very consumer-centric use cases where you can have news updates, or like what's the weather. You could use Lex for that, and then publish it to various messaging platforms. Application bots, and this is where you would have mobile applications. You can add the conversational interface to have that ability available to your mobile app, and both like chatbots as well as voice interaction could be added, and that could be very useful for booking tickets, ordering food, a lot of those transactional based experiences which are starting to get popular. Another very important use case is enterprise productivity bots, where you can increase the efficiency of the workspace. And this is where you can integrate with services like Salesforce for sales data, with HubSpot for marketing performance data, Zendesk for customer service data, and so on and so forth. And then, of course, with the proliferation of various devices, adding the conversational interface to a lot of these devices so that you can actually talk to them, maybe sometimes chat with them, is a popular use case. All of that becomes possible, easy for you to develop using Amazon Lex and AWS Lambda. Quick recap of Lex Benefits again. As you had seen that, built for the builder, so very easy to use. It's a complete chat platform, a chatbot platform to manage the entire life cycle of your chatbots. It has high quality text and speech language understanding, built on the same platform as Alexa, so you get all of that intelligence and the machine learning which goes behind that for your chatbots. It can seamlessly deploy and scale. What this means is you don't have to worry about the scaling aspect at all. And then the deployment, as you've seen, is just a click of a button from the Lex console. It has built-in integration with AWS platform. We spoke about the integration with AWS Lambda, through which you can integrate with the entire suite of services which AWS provides, as well as any external available endpoint. And then this is cost-effective because the model is going with the serverless nature, that it's pay-per-use model. I don't think I've covered pricing here, but Amazon Lex detail page should you can check that out. And then let's talk about mobile applications. There are a lot of useful mobile applications which would also benefit when you add conversational interface to the application. And then I spoke about the lot of information available in the enterprise services, a lot of third-party enterprise services, and you would want to use that rich information, that sales data, the marketing information, and use it in your bot easily. So we've announced AWS Mobile Hub Integration, which is a platform to easily create, it's an existing platform to easily create mobile applications, to create them, to monitor them, to configure them. And now we've integrated Lex bots with the platform. So now you can also easily add the Lex bots which you have created to any of your mobile application easily. There are samples, there are connectors, which you can use to sort of controls to build those easily. The SaaS connectors are another feature which we have recently launched. And this is where you get access to the third-party enterprise services in a very secure manner. It also helps you to get access to the important business object in a uniform manner. So that you're talking about customer data in sort of the same object model, as well as all of the other enterprise services information. There are two types of integrations provided. This particular one is a backend integration, where through AWS Lambda, the integration we saw in Lex, it can talk to the backend, to the connectors, and get that useful information, and then through the Alexa, to the Lex pipeline, so that the model understands and it can do that language or intent slot understanding on that entire pipeline for you. There are 6 connectors which are launched. Those are Zendesk, Salesforce, Marketo, Dynamics, QuickBook, and HubSpot. And so these are available right off bat for you to integrate in your applications today. There is also a custom connector, which then you could use for the 7th or any of the other data stores. Each of these connectors, as you would have imagined, are based on API Gateway and Lambda. And so you understand the sort of the same scale and serverless advantages which come along with that. This one is the client-side integration, and this is where you use the Amazon Lex for the conversational piece for it, and then you can use these connectors if your model allows or the application architecture wants it so, and you can call it from the client side to call into these connectors and get that useful enterprise information in a very secure manner. As you can see, the generic connector could be used to access your business application data, which could be behind the firewall. Again, all of that, securely with the serverless model. And so let's do a quick recap. So first, we looked at creating these serverless chatbots as webhooks. Using AWS Lambda and API Gateway. So this easily gets you going on creating the chatbots, get the webhook, integrate it into your messaging application, and there you go. You have a chatbot available. Next, we looked into adding this very useful, important, and a challenging conversational interface intelligence to your chatbots using Amazon Lex and AWS Lambda. And then finally, we looked at the Mobile Hub integration to add these chatbots to mobile app, as well as the SaaS connectors to securely access third-party enterprise information, and then integrate them into your various workloads. A key takeaway would be a register for the preview for Amazon Lex. Amazon Lex is in preview, so you would have to go to this URL. I'm sure it has all the details for you to register. What that would do is we would whitelist you, and then you would be able to have access to the samples which we have created, both on Amazon Lex side, and then as well as the samples on Lambda as blueprints. So using the Lambda blueprints, you would be able to create the backend fulfillment logic, as we spoke about, very easily. I think the 3 samples we have is a chatbot to create like order flowers, book travel, and there is one more, or you can as well create a custom chatbot for your purposes, and then build your first serverless chatbot using those blueprints. With that, thank you very much. Thanks for joining. I hope you enjoyed the session. Maybe I spoke too fast, but hopefully the concepts were reiterated so that you can take some useful takeaway with you on starting this very exciting serverless bot journey. Thank you very much, and thanks for attending. Have a great rest of your reInvent.